everybody at home. Here comes your warm up. I can find it. There it is. Find the volume of these spheres. Go ahead and clip them out. You're going to want to do that in 3, 2, 1, pause. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1. Okay, here we go, everybody. So, let's go ahead and get to it. So, I'm going to show you on the first one what goes through my mind when I solve for one of those, and then we'll talk to you guys and see what you like. So, when I'm solving one of these, Andrew, can I get your attention up here? What I'm imagining is I'm imagining the cone that fits on the top half of that sphere. I'm imagining that there's this cone fitting on the top half of the sphere. Because once I find the volume of that cone, how many of these cones fit in the top half? Everyone there, how many everyone there were? Two. So a total of how many of those cones fit in my whole sphere? So if I find the volume of that cone, I multiply it by 4, I got myself what I want. So to find the volume of the cone, I take the radius, which is 7.5, times itself, times the height. And the special thing about this cone is that it is exactly as high as its radius. So we multiply that by 7.5. And you get 421.875. 420, I'm going to write that down, 421.875. What's weird about this, though, is that this is the volume of the secret cylinder that fits around that secret cone. So what do I need to do with the volume of the cylinder to find the volume of the cone? I have to divide it by whatever I have to divide it by? 3. Yeah, so I divide that by 3. I get 140.625. So 140.625 pi, that's the volume of the cone. But how many of those cones fit inside of my sphere? Everyone, how many? 4. So I'm going to multiply that number by 4, and I get 562.5 pi miles cubed. So it's like well, that's probably too small for a planet. Is that like a planetoid, or what are they called?
Dwarf planet.
Dwarf planet, maybe. A big old asteroid. I like that. I like that. And then you just multiply that by your favorite approximation of pi, which I'll just use my pi button. 1767.146. The volume's about 1767.146. Okay. Yes, Luke. Sure. Yeah, absolutely. So 4/3, that's how you do it with just the formula, times pi times 7.5 to the third. That'll give you the approximate. It kind of spits out a bit of a nasty exact, so you have to play with that a little bit. That's why you'll see me do it without the pi until the very end. Yeah, Teo.
I just did like the diameter too.
Sure. So the diameter is 15, so 15 to the third times pi divided by 6 gets you the same result. Just sometimes the exact's not so nice. That's why I'll often leave the pi out until the end. Because if you do that without the pi, 15 to the third, oops, whoa, that was about to get bad. I don't know if you guys saw that. Divided by 6, you get that number with a pi next to it, and then you're good to go. How many of us feel like spheres are easy peasy, lemon squeezy? Love it. Divided by what?
Divide the volume by pi. So just
Sure, you could definitely do that, yeah. All right, come on up in 5, 4, 3, 2, 1. Chris, talk to me. How am I going to find the volume of this guy over here, the one on the right? Sure. Ah! Sorry, that was 12 to the 33rd. That's a little bit different. That's 12 times, that's 33 12s multiplied together. That's not what we want. Go ahead. Okay. and you divide it by 3, and then you just glue a pi on it, right? Yeah, I love it. So 2,304 pi inches cubed, which is approximately, if I multiply that by 3.14, 7234.56. 7234.56. How many of us were either able to get that or see how we got that and aren't too alarmed? You guys doing okay out there? Perfect. It's not so bad. It's not so bad. So, guys, I didn't get to send my time card over the weekend. I have been burning myself out working on getting the 7th grade field trip thing put together. Thank you to everybody who's already turned in your yellow slip. Remember, your yellow slips are due to the front office by Thursday if you want to get on there. If you had to go to the meeting on Friday at Mr. Snyder's room, that stuff's also due on Thursday to Mr. Snyder. But there will be a list tomorrow at the front office replacing the one that's the qualifying list. That is, if you qualify and you've got your paperwork in, it'll actually tell you that you're good to go, like for both the paperwork and the qualifications, okay? It might even tell you what group you're in for now, but we'll see. We'll see if we can get that in time. Like I said, I'm not going to be getting much sleep this week. I actually dreamed last night that I came to school today and that the field trip was today, and I like messed it up. And so I was like scrambling to get everything put together, and I was like, I think I can do it. I think we're good to go. And I had all the signs for the buses, and they were like, hey, 2 busfuls of kids just left with no adults on there. And I'd be like, well, and that's that. Okay. Hey, it's a 141st day of school. Did you guys know that 141 is the sum of the sums of the divisors of 1 through 13? Let me explain. I'm not going to do I'm only going to do 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. Hey guys, what are all the numbers that go evenly into 1? 1, so I'm going to write that down. What are the numbers that go evenly into 2? 1 and 2. What are the numbers that go evenly into 3? 1 and 3. What are the numbers that go evenly into 4? 1, 4, and 2. What are the numbers that go evenly into 5? 1 and 5. What happened to that book that I just knocked over? It fell. Okay, so if we add all these together, like 1 plus this is 1. What's 1 plus 2? What's 1 plus 3? 4. What's 1 plus 4 plus 2? 7. What's 1 plus 5? If we do that all the way out to 13 and then add all those numbers, you get 141. No. Oh, it's International Haiku Day. Yay! Can anyone tell me what a haiku is? What's a haiku? What's a haiku? Let's go for, go William. Guys, can't hear? Can you be specific? No. Okay, Nitty, can you be specific? The first line has 5 syllables. Yes. The second line has 7, and the last line has 5. They're one of my favorite types of poetry. I wrote one about today in our time card that you'll see this afternoon when I finally get it sent. Here it is. Today is the day we celebrate poetry, written as haiku. Yay! Yay! Thank you, thank you. It turns out I actually got schooled once by, I had a student, was that last year or 2 years ago? But in any case, she actually told me that this whole time I thought I'd been writing haiku, but what I'd really been writing is something called senryu. The difference being, haiku is about like the beauty of nature, and senryu is about the folly of man. Which in my mind, math fits very much into that category. It's us just sitting there like starting to count and then just like, look how cool this is. Meanwhile, deer prancing around and it's like, I'm not even paying any attention. But anyway, I love it, guys. My recommendation is like, for example, I love it. I had a whole class of students do this once because we were talking about haiku, where anytime their RISE test had a question that was like a free response, they wrote it as a haiku. So like if it was like, what is the measure of this angle? Like write it as a free response. It would be like, the angle here is 112 degrees, my dude. Yeah. You know what I mean? Yeah. So I highly recommend it. Hello.
I know how to write an offensive haiku.
I better not, but I think we'd better keep that off. I am recording after all. My favorite is, if you can't think of a way to finish a haiku, refrigerator. All right. Come on up in 5, 4, 3, 2, 1. Lucas, what's our first essential question today? Yeah. May we practice calculating the volume of a sphere? Because I realized we never had a day to practice it. So we're going to do that today. Tomorrow we're going to do our circular solid skill review, and then we're going to do our skill check on Wednesday, okay? By the way, Jeopardy! Famous Buildings, completed in 80 AD, which is fun to say. This Roman building housing gladiator shows, animal circuses, and other diversions is a must-see if you visit Rome. That is the Colosseum. That is the Colosseum of Rome. And then the Pictionary is Ibid. Does anyone know what Ibid means? Yeah.
International buildings in.
No, yes. It's Ibid means the same as previous.
What?
That is the famous buildings. Ibid, famous buildings. The answer is the same to both of these this week. The idea is I give you a clue in words, and I give you a clue that's a picture.
Why is it called the
I think it's Latin for the same. It's kind of like if you'll see it at the bottom of like text. So like if you look at bibliographies, it'll be like I got this from Napoleon's notes from the battle at Waterloo, page 14, and then it'll say Ibid, meaning I got it the same place. I also found it in Napoleon's notes for the Battle of Waterloo, page 18. Yeah. Oh, heavens no. I know. Someone erased all my stuff up there, and it makes me sad. It's on my to-do list, but I got to tell you guys, I'm going to be kind of falling apart until after the field trip on Monday because, like, that is right now ruling my life. Like, I've got to get that. I know. A week from today, we're going to have that field trip. You guys excited? Yeah, it's going to be super fun. Okay, anyway, can I get you in 5, 4, 3, 2, 1? Shh. Underneath all this, got a pencil? Spheres again. Yep, spheres again. I would like everyone draw a sphere and give it a belt. Yep. So you draw a circle and you give it a belt. Now it's a sphere. If I tell you that the diameter of that sphere, that is the distance from one side of the sphere to the other, maybe. Apparently it wants me to do the radius, but that's not what I want to do. If I said I wanted it from here to here, thank you so much. Whoop. We're going to say that the diameter of this sphere is 4.8 millimeters. It's like an itty bitty bobble. I want the exact and approximate volume of that sphere. Please talk to each other, and here we go. It's itty bitty. Teach. What? No? It's just fun to say itty bitty in that voice. It's teeny tiny. Ewan, did you make it to the next round?
Yes.
That's awesome. Congratulations. That's exciting. I know there's a lot of people running for things in this class. I'm very excited for all of them. You did too? That's awesome. And of course, Teo as well. Ooh, and you guys are partners. Drama. Just kidding. You guys are both awesome. This is like what I love. I love it when it's like, I'm happy either way. I'm happy either way. And Jack's running too. Well, you're secretary historian, right? No, vice? President? PR. There we go. I was going to get there eventually. That's right. I forget because there's so many people in this class who are running for something. It's cool. Public relations. Mm-hmm. just for political reasons. I will rule the seventh graders with an iron fist. Ah. Oh, wow. Wow, 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 wow. Okay.
Are we gonna? There gonna be donuts at the field trip?
Oh, the donut shop. I mean, it better be open. I'm gonna tell you, it was open last year, and like I think they probably made $3,000. Like pretty much every seventh grader bought at least one donut. It was bonkers. That was bonkers last year. Like we have to make the basically when you get to the donut shop stop station, I stand in front of the donut shop, and the parents like, who's not buying donuts? And it's like three of us, and then they like go over to the barber shop, and then when you're done buying donuts, they go to the barber shop and like.
Find money
Go
for
to
the
the,
donuts. You can bring money for the donuts.
oh, certainly. You can bring money. There's also a gift shop. You can bring money to the gift shop. I don't mind. What's that? Oh, I don't know about that. I don't know, but I'm gonna go on the weekend before. So like, I'm gonna go on the weekend before.
Listen, Peterson. A sphere doesn't have a circumference, right?
It sure does.
Okay.
It's weird. It's the circumference is the distance around that belt.
Okay.
The distance around that belt. Mm-hmm. I don't know. I'm gonna go on Saturday next week, and I think if it's open, like the Panning for Gold was open when we went last year, and that was really fun. I'm gonna go with my daughter on Saturday next weekend, and I'm gonna just kind of figure out what's still open so I can kind of figure that out. I should have done that this weekend, but I was doing paperwork for the field trip. Oh yeah, yeah, yeah. We'll find a place for you, Lucas. Don't worry, and we'll get you next year. Okay, can I get you in 5, 4, 3, 2, 1? Shh. Casey, talk me through it. What are we gonna do to find the volume of this sphere? So we got 4.8 divided by 2. The radius is 2.4. Raise it to the third power. Consider it done. Ah! Okay, got it. Multiply by what? By 4. Okay. Done. And there it is. You're exact as that with a pi. 18.432. 18.432 pi millimeters cubed. And then the approximation is you multiply that by your favorite approximation of pi, about 57.906. 57.906 millimeters cubed. Okay? Can I get you guys in 5, 4, 3, 2, 1? Now, guys, on the rise test, they're not even going to bring this up, but I'm standing so close to it, I just want to bring it up anyway because it's kind of a cool thing. Does anyone think they know what the surface area of a sphere is? Do you think you might know? So, did you already know it, Andre? Okay, then sit tight. Let's see if we can get someone who hasn't heard it before, and then we're going to have you tell us what it is, okay? Have you heard it before, or do you think you know? What do you think it is?
Could it be like
Ooh, you've got an idea there. It actually, let me show you. I'll show you guys. There's a circle inside of the sphere. Do you guys see that circle that's in the middle of a sphere? That's called its great circle.
circle?
And I'll tell you right now, it has something to do with its area. So the question is, if I were to take if I were to take a circle that size and use it to wrap it around my sphere, would I need more than one of those or less than one of those to wrap it? So how many more do you think I would need? How many of these do you think I need? Two. Pi of them. Three of them. Andre, you want to tell us how many? Ooh, it's actually 4. It's bonkers. If you take the area of that circle, exactly 4 of them fit on the sphere. So, just out of curiosity, the surface area is 4 pi r squared. Isn't that weird? Anyway, they're not going to test you on that. That's not on the skill check. That's not on the self-assessment. But how many people here think that's just bonkers? And it's like, I am not kidding. For more than 2,000 years, human beings have been trying to come up with a simple picture to illustrate why it's just 4 and have failed miserably every time. There's a way to prove it. You can do it with calculus, but they've known it since before calculus. Yeah, go ahead. Caitlin, you have a question? Oh, Nitty.
Would you like wrap a circle around the top, like a lid or something?
Yeah, the problem is that Imagine taking a circular piece of paper and putting it on top of a sphere. Now try to get it on there without crinkling it. It would have all these crinkles. And what do you do with those crinkles? Yeah.
That's sort of like circumference times circumference.
Pi r. Is it? Wait a minute. So the circumference is 2 pi r. No, because then it would be 4 pi squared r squared, which that's crazy because it is circumference squared divided by pi, which I don't know. That's crazy. Anyway, when I say teach, I want you to say, okay, I want you to work on any of the self-assessments from this module. Spheres opened today, so if you've done them all, you can work on spheres. Otherwise, start at the beginning and work your way down.